Hello friends, this presentation deals with evaluation of a new diagnostic test and I am Dr. A.P. Kulkarni. The lesson objectives for this lesson are that at the end of the session, the participants would be able to enlist the indicators for evaluation of a diagnostic test. They would be able to describe and calculate the sensitivity, specificity and predictive power of the test. They would be able to describe the utility of ROC curve and method, how it is to be drawn and used. They would be able to describe the utility of kappa statistics in evaluation of the diagnostic test. The indicators for evaluation of the diagnostic test are the validity, the reproducibility, the acceptability and the feasibility. The validity includes the calculation of sensitivity and predictive power of the positive and negative test. The word gold standard would be used in this presentation, and the gold standard is a universally accepted test with which the results of the new diagnostic test will be compared. The validity indicators calculated are with reference to the selected gold standard. So if the gold standard is different, then the calculation and the calculated values of the indicators of validity would differ. So this is an example of the table that we get at the end of the study. So herein we select certain individuals. The calculated sample size is obtained with the help of the statistician, and we apply the gold standard diagnostic test as well as the new test in the same individual. So we get the two results in an individual, that the result with the gold standard and the result with the new diagnostic test for each individual included in the study. And we get a table, say 2 by 2 tables or something looking something like this. So here are the true positives are the individuals who are declared as having that disease by the gold standard and are declared as positive, that is having the disease, by the new diagnostic test. The false positives are the individuals who are declared as not having the disease by the gold standard but are declared positive by the new diagnostic test. False negatives are the individuals who are declared as having the disease by the gold standard but are declared negative by the new diagnostic test. And the true negatives are the individuals who are declared as not having the disease by the gold standard as well as the new diagnostic test. So A are the true positives, D are the true negatives. So A are the true positives and D are the true negatives, and these are the false negatives and these are the false positive individuals, and N is the total number of the individuals selected for the study on whom the study has been made and the test has been carried out. Both the tests have been carried out in N number of individuals. So this is an example of the result that we may obtain wherein the 300 individuals on 300 individuals both the tests were carried out, that is the gold standard and the new test. This is an hypothetical example, and we obtained the result something like this. In 90 individuals were true positives, 180 individuals were true negative, and these were 20 were false negative, and the 10 individuals were false positives. So how do we calculate now? This is the steps. This is how we calculate the sensitivity. Sensitivity is the ability of the test to detect the disease in those who actually have it, and it is calculated by the values in this column, that is the first column in which the values are there. So A upon A plus C, that is the true positives divided by the total number of the individuals who are declared as having disease by the gold standard. So A upon A plus C will give you the sensitivity. A test that yields minimum false negative results is the most sensitive test. So in this example, the sensitivity is given by 90 divided by 110. Either it is expressed as 1 or it is expressed as percentage. So if it is expressed as percentage, this test is has the sensitivity equal to 81.82%, or sensitivity is equal to 0.8182. The specificity is calculated with the help of the values in this particular column, and the specificity is ability of the test to detect absence of disease in those who actually do not have this disease. So it is given by the calculating D divided by B plus D, that is the true negative divided by the number of individuals, total number of individuals who are not having the disease. A test that yields minimum false positives is the most specific test. The example, in this example, the specificity is given by 180 divided by 190, so it is 0.9473 or 94.73%. The predictive power of the test, predictive power of the positive test, is given by calculating the values in the first row, not in the columns. For the sensitivity and the specificity, we use the values in the columns, while predictive power of the positive and negative test, we utilize the values in the rows. So predictive power of the positive test is the probability that a person will have the disease if the test is positive. So it is given by A upon A plus B, so that is true positive divided by the number of individuals who are positive with the new test. A plus B are the individuals who are declared positive by the new test. And this is how it is actually calculated. The predictive power of the positive test will be 90 divided by 100, that is 0.9 or 90%. The predictive power of the negative test, for calculating, we use the values in this column, in this row. It is the probability that a person will not have the disease if the test is negative, and it is given by D divided by C plus D. Predictive power also depends on the prevalence of the disease. The predictive power is therefore the function of the test as well as the prevalence of the disease. Sensitivity and the specificity are the functions of the test itself, but the predictive power is also, in addition to the test, it is also a function of the prevalence of the disease. So it will differ or it will be different if the prevalence of the disease is different. This is an example wherein we have calculated the predictive power of the test, wherein the sensitivity of the test was 50% and the specificity was 90%. So in all these three instances, this is the instance number 1, this is the example number 2, and this is the example number 3. In all these cases, the test had the sensitivity which is 50% and the specificity which is 90%. But you will see that the predictive power of the positive test in this example, that is 25 divided by 120, is 21%. In this case, the predictive power of the positive test is 75 divided by 160, that is 47%. And in this case, the predictive power is 125 divided by 200, that is 63%. So other things remaining constant, the predictive power will increase if the prevalence of the disease increases. Then we can say with this example that if the sensitivity and the specificity of the test is constant, then it will be highest in the areas where the prevalence is highest, and it will be lowest in the where the prevalence is lowest. So predictive power will also depend on the prevalence of the disease. Then how do we calculate the predictive power of the negative test? So for this we will utilize the values in this particular row. So it is given by 180 divided by 200. 180 divided, so 0.9 is the predictive power of the negative test. Reproducibility is the ability of the test to give consistent results when repeated under similar conditions. So reproducibility will depend, apart from the test per se, it will depend on certain factors like the observer errors, like the errors in the instrument or the procedures and the biological variation. So observer means the person who is conducting that test. On his technical ability, the reproducibility will depend. So you will see that the reproducibility depends more on the extraneous factors than on the test itself. And the improvement in the reproducibility can be obtained by training of the personnel, by standardizing the procedures and the instruments, and by multiple testing and averaging. So these are the ways by which the reproducibility of the test can be improved, because it depends on the extraneous factors like observer errors, errors in the instrument and procedures, and the biological variation. Points to remember is that the new test is always compared with the established test, that is the gold standard test. And all measures are relative to that golden standard and would change if the golden standard is changed. So when you are reporting the indicators of the evaluation of a test, you must invariably mention what gold standard was used against which the test was compared, because the results would differ if the gold standards are different. Now, if different cutoff points are set for the new diagnostic test, if the results of the new diagnostic test are obtained in the form of a ratio variable, and the gold standard test is giving the result, say, in the form of whether the disease is present or not. So if the different cutoff points are set for the new diagnostic test for declaring as person as a positive or having the disease, negative or not having the disease, then the sensitivity on the specificity will change. For the new diagnostic test, therefore, if the different cutoff points are set for diagnosing a person as having the disease or not having the disease, then the indicators of sensitivity and the specificity will change. The observed indicators are therefore are also subject to the sampling variation. So we must calculate the confidence interval, 95% confidence intervals for the indicators. So the indicators which we calculate are called as the point estimates of the sensitivity, specificity, the predictive power of the positive and the negative test, and we must calculate the 95% confidence intervals for the point estimates that we have calculated. The accuracy of the test is how close the estimates of the new test are to the truth, and the truth is what the gold standard says. So for accuracy, the gold standard is a must. So for commenting or determining the accuracy of the test, the gold standard is a must. The reproducibility is how close are the repeated estimates of the new test to each other. So for reproducibility, we must repeat the test in similar circumstances, and the gold standard is not required here. So for reporting the results of accuracy, we require the existence of a gold standard. But for reproducibility, we do not require the gold standard because for reproducibility, we have to compare the results of the repeated estimates obtained by the new test. The next concept which we must explain in this presentation is the ROC curve. ROC is the full form of receiver operating characteristic, and ROC curve is therefore receiver operating characteristic curves. It has got two uses. One is deciding the cutoff points and comparing the two tests. So as we have said previously, that the new test may be, the results of the new test may be in the form of a ratio variable, that is the just like in hemoglobin, like or like say blood sugar level. So these are the examples of the ratio scale variables. So the results of the new test may be obtained in the form of a ratio variable, whereas the gold standard may be expressed in the form of a nominal variable, that whether the disease is present or not. Then in that case, we have to decide the cutoff point for the test, that at this cutoff point we will say that the disease is present, and if the values are say lower than that particular value, we will say that the disease is absent, say for the indicator like blood sugar level. So in the blood sugar level, if the cutoff point is say 100, then we will say that if the value the value obtained with the new diagnostic test is 100 or above, then we will say that with the help of the new test we have diagnosed it as a diabetes. And if the value is less than 100, then we will say that the new test has declared the person as not having diabetes. If it is something like, say, hemoglobin level with the new diagnostic test, then we may say have cutoff point, say, as 10 grams of hemoglobin. Then we will say that if the value is 10 or less, anemia is present. And if the value is above 10, we will say anemia is not present as far as the new diagnostic test is confirmed. So the dilemma is that at which cutoff point for the new diagnostic test we will say that the disease is present or absent. So we have to decide when a new diagnostic test is there and its results are obtained in the form of ratio scale, we have to decide cutoff point for diagnosing the presence or absence of a disease with the help of the new diagnostic test. Then another use of the ROC curve is comparing the two tests. We may have two new tests and we want to compare these two tests with the gold standard. So in that case, which test should we select? So ROC curves come to us for the helping of choosing between the two new diagnostic tests when they are compared with one gold standard. The example here is that the gold standard gives the result as having the disease and not having the disease. And the new test, as we have explained over here, the new test is giving the result in the ratio scale, like in hemoglobin percentage or the glucose level, etc. So for a given result with the new test, the sensitivity and the specificity would change. So in case of hemoglobin, for example, if 9 grams is chosen as the diagnostic level, then the sensitivity and the specificity would be some value. And if it is changed to 10 grams, then the sensitivity and the specificity values would change for the new diagnostic test. Same with the glucose level also. The challenge is therefore to select the best cutoff point for the diagnosis with the new diagnostic test. So for drawing the ROC curve, what do? We select a diagnostic cutoff point with the lowest value for the new test. So it is in a ratio scale, so it will have a range of the values. It will have the lowest value, the highest value, and the other values will be in between them. So we select the lowest value for the new test. Then calculate and record the sensitivity and the specificity for the selected value, that is the lowest value. Then we repeat for the values in the ascending order. So we go for the next higher value and calculate the sensitivity and the specificity for the selected value of the diagnostic level. And like this we repeat and we reach to the highest value. So for the all possible values in the range for the new diagnostic test, we have got that many values of the sensitivity and specificity. We have the value of the sensitivity for the lowest value, we have the sensitivity and the specificity for the highest value, and we have got the sensitivities and specificities for the intermediate values. Then we draw the chart. How do we draw the chart? So we draw the chart in this way, that on the y-axis we have the sensitivity for the given diagnostic level, and on x-axis we have 1 minus specificity. It is not the specificity, but it is 1 minus specificity. So on the x-axis for a given level of diagnostic level with the new test, what was its sensitivity and what was the value of 1 minus specificity. So on y-axis we have sensitivity, on x-axis we have 1 minus specificity. The maximizing the sensitivity corresponds to some large value on the y-axis. So at this point we have got the highest value of the sensitivity. So for this diagnostic value of this cutoff point, which corresponds to this point, the sensitivity is maximum. The maximizing the specificity corresponds to some small value on the y-axis. So at this point the 1 minus specificity is 0. That means specificity is maximum at this point. So for this level, for this, the value of the diagnostic test, the diagnostic value, the cutoff point that has been selected over here, is here is the highest specificity and the lowest sensitivity. At this point, we have highest sensitivity and the lowest specificity. So we will have to select some point which compromises and will give the best results for the sensitivity and the specificity, because at this point which correspond the value of the diagnostic test corresponding to this point, we have the highest sensitivity but zero specificity. At this point we have got zero sensitivity and 1 minus specificity is 0 over here, so we have got the highest specificity at this point. So somewhere here will be the cutoff point that will be selected. So area under curve is an important measure of accuracy of the test, and it is calculated by the software because the calculations are quite cumbersome, and so we take the help of the software for calculating the area under curve. So if the area under curve has got the value between 0 to 1. So if the area under curve is 1, then the curve consists of two lines. One is the vertical line and another is the horizontal line. So this is the vertical line and this is the horizontal line if the area under curve is 1. So what do you mean by the area under curve? It is the area which is on the right of the curve and below this particular curve. So the entire area is covered. That's why the area under the curve in this case, wherein the curve looks like this, the area under curve is 1. If area under curve is 0.5, we get a diagonal line. So something like this, we get a diagonal line. So here, such a line, if we get the curve something like this, it indicates that the test that cannot discriminate between a normal and abnormal person, normal or abnormal, or the person with the disease and person without the disease. The new test will not be able to discriminate. If the curve is something like this, then we will say that that it is the best and the ideal, and the results are almost identical to the gold standard. So these two are the extreme cases that we obtain. We may obtain the curve something like this over here, but those tests are practically useless tests. We don't recommend those tests which give the curves below this horizontal line, below and to the right of the horizontal line. So in practice, we get a line which will be something like this, and then let us see how we compare the two tests with the area under normal curve. So these are the two tests giving the curves something like this. The blue line indicates the ROC curve obtained with the test number 1, and this blue line indicates the ROC curve obtained with the test number 2. And area under curve for this test is 0.83 with 95% confidence intervals, 0.73 to 0.87, and for this test the area under curve is 0.91. So these are the point estimates of AUC for this test. This is the point estimate for this test, and these are the 95% confidence intervals. So here the area under normal curve for this test is higher than this one, and therefore we will choose this test for the practical purposes over this test because it has got a lesser area under normal curve. So this is the first use of ROC curve, that is we are choosing the test which has got the higher area under normal curve value. Then the second use is to choose the cutoff point for a given test. As we have said previously that the new test is having a ratio, the results of the new test are expressed in the form of a ratio variable, and the gold standard test is in the nominal, the results are in the form of a nominal variable, that is the test is positive or negative. Positive means having the disease and negative means not having the disease. Now this could be any test, it could be say blood sugar level or any test with the new diagnostic method. Now which diagnostic value will you select as far as the new test is concerned. So we have obtained the value 64, which is the lowest value for the new diagnostic test, and 161 is the highest value obtained for the given sample in our case. So if the 64 is considered as the diagnostic value and the result with the new test is declared as positive if the new diagnostic test yields a value 64 or above, then the sensitivity is 1 and 1 minus specificity is 1. That means the actual specificity over here will be 0. So sensitivity is 1 and the specificity over is 0. So such a situation is not acceptable to us. So this value will not be acceptable to us. So now come over here. Here the sensitivity, this is the highest value obtained in the sample for the diagnostic test. So if this value is selected, the sensitivity is 0 and 1 minus specificity is 0. That means the specificity is 1 over here. So this is the extreme, this is the extreme result obtained, that here the sensitivity is maximum and the specificity is lowest. Here the sensitivity is highest but the specificity is lowest. So we have to compromise and have a value somewhere in between. So which value will we select? So here we have the values of sensitivity and 1 minus specificity. So we also have the value of sensitivity. So here 1 minus specificity is 1. So that's why the sensitivity is 1. Our sensitivity is 0 over here. Because sensitivity is 0, the value 1 minus specificity is 1 over here. So similarly, we calculate the values of the specificity. And in this column, we calculate the values of sensitivity plus specificity for a given diagnostic value of the new diagnostic test. So here the sensitivity plus specificity is 1 because the sensitivity is 1 and specificity is 0. Here the sensitivity is 1 and the specificity is 0.1163. So the total of the sensitivity and specificity is 1.1163. So we have to choose or find out the value which is maximum in this column, and the maximum value obtainable is in this row. So we have to find out the row in which there is the maximum value against in this column, which is the sensitivity and the specificity, and this is the maximum value, and this is the diagnostic value. Therefore this will give the optimum results, that it will have the sensitivity 0.8932 and specificity of 0.7923. So we have compromised for sensitivity and specificity over here, and this is the value which will give us the optimal result. So this is how the ROC curve helps us in choosing the diagnostic cutoff points for the new diagnostic test. So we identify the row where the total of the sensitivity and the specificity is highest. So this is the row in which the total of the sensitivity and the specificity is highest. So the corresponding diagnostic value, which is 102.5, will be the diagnostic cutoff point for the new diagnostic tests. The next point which we will have to discuss is the kappa statistic. It is the agreement between the two or more tests by chance or the otherwise. Whether the agreement between the two tests, we try to find out whether there is an agreement, and we also try to find out whether this agreement is by chance. And we determine the statistical significance of the agreement. If the significance is there in the by application of the statistical test, it means that the chance element in the agreement is ruled out. So agreement could be a chance occurrence or it is not chance occurrence. If the statistical significance shows that there is a significant agreement, that means the chance element is ruled out. So here is the result wherein the gold standard results and the new test results are obtained. So A are the individuals wherein both the gold standard as well as the new test have declared them as disease present, and D are the individuals in which the disease is absent by both the tests. So here The observed frequency of agreement is therefore A plus D, that is 90. So out of 100 instances, in 90 instances, the agreement between the two tests was observed. So what is the expected agreement? For expected agreement, we multiply, for example, for the A cell, we want to find out the expected agreement. So here, the row corresponding to this, row total corresponding to this is this 36. And the column total corresponding to this value is this. So 36 multiplied by 34 divided by 100. 36, that is A plus B. 34, that is A plus C, and divided by 100. So 12.24 is the expected agreement for this cell. And for this cell, the expected agreement is given by multiplication of this cell with this cell divided by this. So C plus D, that is 64, multiplied by B plus D, that is 66, divided by 100, that is 42.64. And the total of this is 54.88. So if this would have been a chance agreement, then we would have expected the agreement in 54 or about say 55% of the cases. 55 cases in this example. We say percentage because this number is 100. So if it would have been chance agreement, it would have been in around 55 cases. But the agreement is in 90% cases. So it is beyond what is expected by chance. And so we can say that this is a fairly high number beyond the chance element. We can apply the chi-square test for this table and find out the statistical significance. So how do we calculate the kappa for this table? Kappa is obtained by the observed agreement minus expected agreement divided by total agreement minus expected agreement. So O minus E divided by N minus E. N is the total number of individuals. So 90 divided by 54.58 divided by 100 minus 54.88 is 78%. So the kappa statistic for this table is 0.78 or 78%. How do we interpret the kappa values? The kappa values are interpreted in this way, that if the kappa statistics is less than 0, then there is no agreement. It may be a negative value. So there is therefore no agreement. If the kappa value is 0 to 0.19, it is a negligible agreement. If it is 0.2 to 0.39, it is minimal agreement. If it is between 0.4 to 0.59, it is a fair agreement. If it is 0.6 to 0.79, it is a good agreement. And between 0.8 to 1, it is an excellent agreement. And we see that in our case, it was 0.78. 0.778, or it was say 0.7. If it is 0.7783, then we would say that it is a good agreement. If it would have been in this range, then we would have said that it is an excellent agreement. So in our example, since the kappa value was 0.78, we would say that there was a good agreement. And if the statistical test chi-square shows that these are significant observations, chi-square gives you probability say less than 0.05, then we will say that good and significant agreement. So this finishes this presentation, and for the further reading you can go to these two books written by me. One is the Basics of Research Methodology, published by Paras Medical Publisher, and this is the website from where you can obtain these books or purchase these books online. This is the book Basics of Biostatistics, written by me also. This is the second edition by CBS Medical Publisher, and you can purchase this book online from this website. You can contact me at this address. You have got any difficulty on this presentation, this is my email ID. Thank you for patient listening. And here we finish the presentation.